Alright, this video is to review the volume formulas from Unit 4, circle, segments, and volume. So we have two different formulas, and they go with two sets of solid figures. So we can have a cylinder and a prism. Cylinders and prisms use the same formula of volume equals base times height. Remember that this big B, base, it really means the area of the base. And so we could have several different types of areas. So for cylinders, our base is going to be a circle. That's pi r squared. For a prism, we could have a square. That's side squared. We could have a rectangle, length times width. Or we could have a triangle, and the area of that base is 1/2 base times height. So we just have to be aware that that big B is the area of whatever base that I have. Pyramids and cones function that same way, except we have 1/3 of that area of the base times the height. And very similarly, this area of the base is going to follow these same areas, depending on what that base is going to be. Of course, for a cone, we'll have a circular base, and my pyramid could function in either one of these bases. So let's take a few minutes and look at some examples, refresh our memory here. So we have an example here of a rectangular prism. So we know we're going to follow volume equals the area of the base times the height. So looking at this figure, this is my base, and it's being pushed out 9 units. So this is really going to be 4 times 3 times 9. So 12 times 9 is 108, right? So 108, and that's going to be yards cubed when we take the volume. Remember, your units are cubed when you're taking the volume. All right, this is a triangular prism. So we have, it looks like a base and a height, width, okay. So looking at this, this is our base here. And then it's being pushed out this specific set of units. So when I use base times height, I'm really using 1/2 base times height times the height. So this is going to be 1/2 the base times the height of my triangle. So if you look at, I wish I could color on here a little bit for you. If you look at this piece here, that's your base. They gave you the hypotenuse, that's just too much information. Then we're going to multiply that by the height of the prism. The height of the prism is what's being pushed out. So it's this little piece here of 6. So this is going to be 1/2 of 48 times 6. So 24 times 6 is 144. And again, we're dealing with yards, and it'll be cubed. All right, this is a cone. So when we have cones, our volume is 1/3 area of the base times the height, 1/3 times pi r squared times the height. So my radius, I don't have one. They gave me the diameter, but we can quickly find the radius. Remember, your radius is 1/2 of your diameter, so this is going to be 4. And the height of my cone is 11. So 1/3 of 16 pi times 11. So 16 times 11, 1/3 times 176 pi. So we'll take 176 and divide it by 3, and it doesn't go in evenly. So this is 176 divided by 3 pi. And we can say kilometers cubed. So if we want an exact answer, we would leave it here. The directions here say round to the nearest hundredth. So I'm going to take 176 divided by 3 and multiply it by pi and get a decimal equivalent. This is 184.31 kilometers cubed, and bam. Okay. All right, so exact and rounded. Just be comfortable with doing both. This is going to be a triangular pyramid. This is the fourth example. Okay. So if we're dealing with a pyramid, we still have that 1/3 the area of the base times the height. So 1/3, the area of my base is a triangle times the height of my pyramid. So very similar triangle when we did the one with the prism. 1/2, the base of my triangle is 6, the height is 8, and the height of my pyramid is 12. So half of 48 times 12, this is times 24 times 12. So I know 1/3 of 24 is 8. 8 times 12 is 96 feet cubed. Bang. Okay. Alright, another one. Alright, what about a rectangular pyramid? So, still using that 1/3. So, we have the area of our base is now length times width. So 1/3, 12 times 6. And then the height of my pyramid is still also 12. So we have a length of 12 and a height of 12. So this is 1/3, 72 times 12. 12 times 6 is 72. If I divide that by 3, I get 24 times 12. And that's 288. And again, with volume, we have units cubed. One more last example here. When we have a cylinder, just move my paper over, save paper. We have a cylinder, so that volume is going to be base times height. And that area of that base is pi r squared times the height of my cylinder. This time I do have a radius of 8, so pi times 8 squared times the height of my cylinder, which is 11. So 64 pi times 11 is 704 pi centimeters cubed. The directions do say to round to the nearest 100th, so I'll multiply that 704 by pi and get that decimal equivalent. And that's your volume review. Remember, if you're doing composite solids, you just add those two volumes together. If you have anything hollowed out, then you would just subtract that volume. Tune into the blog for some reviews for the test that's happening on Tuesday. Happy studying!